Okay guys, Assalamualaikum warahmatullah. Very sorry for the delay. Okay, let's discuss the example that we left in the class yesterday. Okay, for example number 1, for half-wave rectifier with the voltage input given as RMS voltage here, frequency 50 Hz, load resistor 5 ohm. Okay, determine the 4 values here. What's the average load current? Now, if we're dealing with the output of DC, so for this converter, we are converting AC to DC. So the meaningful element is the average. We are not measuring the RMS, but we are going to measure or determine the average. Okay, so the average load current. So what is the amount of current that flows into the load? Then what are the average power absorbed by the load, which is the resistor here, and also the power factor of the circuit, how much the power factor at the point of load view, and also then you have to sketch the waveform of the circuit to compare in terms of how the waveform of input compared to the after rectified by the diode at the output terminal. Okay, for A, average load current, I out, which is the average value, is equal to V out over R, and this V out here is equal to V average over R. V out is a V average. We are dealing with average output, but in terms of average for half-wave rectifier is equal to Vm over pi, and so means that the I out here is equal to Vm over pi divided by R. So you will get Vm over pi R. So Vmax is equal to, because we are given the Vrms here, we have to times SERT2, 240 volt times SERT2 divided by the value of R given as 5 ohm, so 5 times pi, and so you will get 21.6 ampere. Okay, then the number 2, this one is in average, 21.6 in average. Then D, we need to find the average power absorbed by the load. So how much is it? Okay, for average power absorbed by the load, P average is equal to I square R. So please remember this I is I RMS, and the RMS current times the load value resistance of the load. So P equal to I square R, P equal to VI, P equal to V square over R. This is the power equation that you have to remember, and you're going to use it, and the Ohm's law, the power equation. So this is generic knowledge or formula that we use in the your working area later. Okay, or is equal to Vrms squared over R. So P average, and this RMS is equal to Vm over 2R for half-wave rectifier. So IRMS is equal to Vm over 2R. Then when you include this one into your initial formula just now, P average equal to I square R. So I become Vm over 2R square times R. So you get, because given here in RMS, so you have to convert into peak, you have to times SERT2. So SERT2 times 240 divided by 2 times R of 5 ohm, and again square, and times the 5 ohms of the R. So you get 5780 watts for power absorbed by the load. Okay, so next is the power factor of the circuit. So the power factor of the circuit is equal to P over S. So you have to remember again to recall in terms of power factor. The power factor is the angle of P compared to Q. So cos theta is equal to P over S. So you have to remember this power triangle here. The real power, imaginary power, and the apparent power. And P, Q, and S triangle. So power factor is equal to P over S. So you have to find P. P already obtained here. Then you have to find S. S is the input power that comes from the source. So we have to find S equal to V in times the current that flow into the circuit. So in terms of current, so we have the same current that flows from the load into the from the source into the load. But in terms of voltage, so S is equal to what being delivered by the source. So P over S, and S here is the input voltage times the current that flows into the circuit. So current is the same amount, whatever delivered is whatever is the amount that absorbed by the load. We have single line here, so it completes the loop. But the voltage is the generated at the source. Means that we have Vrms of 240 volts times the Irms, which is Vm over 2R. So 240 Vm is the previous amount that we calculate. So when we put in, the value becomes 33.9 ampere times 240, we get 8190 watts. So P divided by 2 divided by S is equal to 5780 divided by 8190. So you will get 0.78 of power factor, or if you convert into percent, it becomes 70.8%. Okay. Then you have to sketch the voltage waveform of the circuit. So you draw in time domain. So draw for the input voltage. In terms of presentation by right, is okay, or is advisable for you to draw in at least 2 cycles. Less than 5, but around 2 cycles is sufficient. Okay. So this is the V in. Then the voltage at the output, V out. So this one measured in the source, this one measured at your V out. So V in times V out. So this is the discussion for this example number 1. You can pause, you can reverse, you can rewind again to see the calculation that we have discussed. Okay, for tutorial 1, the next question that comes after the examples, we are given here the half-wave rectifier, which with the amount or the values of voltage input mentioned in time domain. So Vt equal to 170 sine 770 volt. So you have to recognize, or you have to take note that this is in peak, and just now the value in RMS, now in peak. So I average or I out is equal to V out over R, or Vm over pi, times the 1 over R here. So you get Vm over pi R. So Vm is already here, so you just put in 170 volt divided by pi, and divide by also the value of R, which is 15 ohm. So you will get your value of average, this is average current of 3.61 ampere. Meanwhile, the RMS load current, just now in average, if you want to change into RMS, so IRMS equal to Vm divided by 2R. V peak Vm here, Vmax divided by 2R. 170 divided by 2 divided by 15. So you will get 5.67 ampere. So just a little bit bigger compared to average value. But the most important is that in average lah. But you want to calculate in terms of power factors, we have to calculate the IRMS. So what are the amount of the absorbed power by the load? So P load equal to I square RMS times R. So IRMS we calculate just now 5.67 squared times 15. So it becomes 482.23 watts. Right. So in D, the apparent power supplied by the source. What is the value or the amount of S? So you have to remember again the power triangle PQS. So V S equal to VRMS times IRMS. So this VRMS is the input or the source voltage, which is 170. You have to divide by 2 to convert into RMS, times IRMS that we have calculated just now, 5.67. So it becomes 681.58 VA volt ampere. So this is the amount of P, this is the amount of S. So you will get your power factor by dividing P over S. 482 divided by 681. So you will get 70.8%. So this is the tutorial number 1. Okay, we go to the tutorial number 2. So it was mentioned that the half-wave rectifier circuit has a transformer insert between the source and the remainder of the circuit. So you have to redraw the circuit with the transformer. From the AC source, you have transformer, then go to the diode and go to the load. So we have current that flows into the second windings or second circuit for the load, which is 12 ampere. So you draw and you key in all the related parameters that being mentioned. We have here Vin of RMS 240 volt. We have 20 ohm of load value. We have N1 and N2 of windings. So what is the transformer turns ratio? We need to calculate this value. So as per what we have discussed before, you try to find out what is the average current that flows into the secondary or into the load using the given or the previous formula, which is I equal to V average divided by R, or Vmax divided by pi R. So we have here average current given, so we put in 12 ampere equal to Vm divided by pi divided by 20. So we arrange, we shall get the Vm value of Vmax peak value of 754 volts. So we get this one in maximum peak value. So what about the RMS? So V out RMS is equal to the value that we calculate divided by 2. So it becomes 533.14 volts. Then primary winding ratio divided by secondary winding is equal to the voltage of primary and secondary divided by the voltage of secondary. So you will get 0.45 in terms of turn ratio, and comparing between primary and secondary. Stepping up means that the secondary is bigger compared to primary lah. Okay, determine the average current in the primary winding of the transformer. What are the values of In? So V power that convert means that the Pin is equal to Pout. Ideally, Pin is equal to Pout. P equal to Vi. So or P equal to the amount of current times the amount of winding. So I1 N1 equal to I2 N2. So you rearrange I1 on one side and the other on the other side. So we have the amount of current that in the secondary winding of 12 ampere,